In our last class, we tried to discuss what is meant by composite function, and I gave you an exercise there. So let's look at the correction to that exercise together. So it's a very simple question, and some of you performed wonderfully well, but for the few that made some mistakes, so this presentation will give you the correction to that assignment so that you can note your mistakes. So first, let's see the question. The question reads, given that a of x equals x plus 3, b of x equals 4x, find question A, b of a of x, and question B, a of b of x. So if you look at this question, we are given two different functions. The first function is function A, which is in terms of x, given as x plus 3. And we are given function B, also in terms of x, which is defined as 4x. So we are now asked to look for b of a of x. I want to believe you can still remember this notation. This O here, since we read it as of. So this b of a of x. So in this case now, we are looking for a composite function such that the output of function A will be regarded as the input of a function B. And question B here simply means we are looking for a composite function in which the output of function B will be set as the input of a function A, and that's what we call function of a function. So let's look at the solution together. So we are going to have, as for the first question, we have b of a of x. So don't forget that in algebraic form like this, when you want to interpret it, this simply means this a of x, its output will be set as the input for function B. So, and that's why we have another way of writing this if we don't want to use this O notation. So in that case, we have b of a of x equals b into a of x. So this is another way of writing it. And I want to believe from our knowledge of polynomial, you are more familiar with this method of writing it, but they actually mean the same thing. So in this case now, it's very clear that whatever a of x is, the output of a of x, we set it into the function b. So that is what it means. Now, what's our a of x? A of x is defined as x plus 3. So it simply means what we have here is just as b into x plus 3. So what does that mean? It simply means a of x, which is defined as what? X plus 3. So we slot it in here. So this expression becomes b of x plus 3. So the reason why you're having x plus 3 here is because a of x has been defined as what? X plus 3. Now, what next? So we now have b of x plus 3. So the output of a of x is already x plus 3. So this output now, which is x plus 3, we are now going to set it as the input for b of x. So we now come back here. B of x is defined as 4x. So instead of writing this x now, if you want to interpret this, x now will be interpreted as x plus 3. So that we are going to have the next step now. We have 4 into x plus 3. So what has happened there is that we are trying to interpret b of x equals to 4x. So if b of x is equals to 4x, so b of x plus 3. So it simply means instead of x now, we are having x plus 3. So if you follow this definition, 4 times, instead of this x now, we put x plus 3. That's why you're having 4 into brackets x plus 3. So if you simplify this, you just expand the brackets. So please don't forget, b of x plus 3 results to 4 into bracket x plus 3 because b of x is defined as 4x. So if this is b of x, remember your polynomial. So if you want to look for b of x plus 3, it simply means x now is equal to x plus 3. And that's why instead of having x here, we just substitute x plus 3, because b of x has been defined as what? As 4x. So we just expand this. If you expand this, you have 4x plus 12. That is 4 multiplied by x, 4x, and 4 multiplied by 3, you have what? 12. And that's the final answer to that question. So let's do for the b part. As for the b part, we have a of b of x, meaning that the output of b of x, which is 4x, is going to be the input of a of x. So let's look at that. So a of b of x can now be written as a into b of x using the alternative notation. So here now, it simply means whatever b of x is, whatever the output of b of x is, we slot it into the function what? A. So the output of b of x will serve as the input of what? Of a. So what is the output of b of x? The output of b of x is what? 4x, which simply means we replace this b of x with what? With 4x here, so that we are going to have a into bracket 4x. So why are we replacing this with 4x? Because b of x has been given as what? 4x. So we have a into 4x. So the output of b of x, which is 4x now, will now be the input of function a. So what's the definition of function a? So the definition of function a is a of x equals to x plus 3. Again, this b of x, the value is what? 4x, and that's why you're having 4x here. Please don't forget. So this b of x is given as 4x. That's why we substitute 4x here. So now we now try to define this. The value of a of 4x, if a of x is x plus 3, all we need to do is just, wherever we see x in this definition now, we are going to substitute with what? 4x. So if you do that, you are going to have 4x plus 3. Why? Because a of x is equal to x plus 3. So instead of this x now, we slot in what? 4x plus 3. So because a of x is what? X plus 3. And this cannot be simplified further. So that's how we leave our answer. That is, the answer is 4x plus 3. So that's the final answer to that very question. And that answer the last checkpoint I gave you. So let me seize this opportunity to solve one more example, so for better understanding. So what example 2? Let's have the question. The question says, given that f of x equals 3x, g of x equals x plus 4, and h of x equals x squared minus 1, evaluate a f of g of h x, b, hence find the value of f of g of h of minus 2. So look at this question now. We have how many functions now? We are given 3 functions, f of x, g of x, and h of x. Now look at it. We have to find their what? Their composite. That's f of g of h of x. So how do we do that? That's for the question A. Let's look at the panacea to that question. So we are going to have, for the question A. Now don't forget that if you want to evaluate this now, let us first interpret this now. So we start with the innermost bracket, that's g of h. So that is, whatever the output of h is, that will serve as the input of what? Of g. And both the result of what we get for that is going to be the input of what? Of f. So we can say f of g of h of x as given in question. We can use another notation to represent it. If you use the other notation, we are going to have f of g into h of x. So you can see what I'm doing there now. I'm dealing with what is in this bracket first. This g of h actually means g of h of x. So this g of h, I'm dealing with it first. It simply means whatever the output of h is, we slot it in as the input of what? Of g, and this is what it means. Now from here now, what do we do now? We go back to the question. This h of x is given as what? S squared minus 1. So we slot in x minus 1 as an input for what? For g. So if we do that, we are going to have f of g into bracket. Instead of writing h of x now, I will now write s squared minus 1 because h of s has been given as s squared minus 1. So instead of this h of s, that's why I'm having s squared minus 1. Now the next step now is g of s squared minus 1. You go back to the definition of g of x. G of x is what? X plus 4. So if you want to interpret this now, anywhere you see x in the original function, your input now will be what? S squared minus 1. You substitute it with s squared minus 1. So this x here, if you want to interpret it here, it becomes s squared minus 1. So you do that, you have f of, now instead of x squared, instead of this x, I will just put s squared minus 1. Then don't forget plus 4. So we have s squared minus 1 plus 4. So I have interpreted this now. Now from here, we have s squared minus 1 plus 4. I can simplify this. Minus 1 plus 4 will give me 3. So this is the same thing as f of x squared plus 3. So s squared plus 3. So that's the result. Now from here now, this is f of s squared plus 3. It simply means this output that we have now, which is s squared plus 3, we are going to use it as an input for the function f. So where is the function f? The function f is what? F of x equals to 3x. So that simply means if you want to interpret this now, we can rewrite it as an alternative symbol. So this simply means this O means f into x squared plus 3. F into x squared plus 3. So what this simply means is that instead of this s squared plus 3 now, if you go back to the function, we have f of x is originally defined as what? 3x. So instead of this 3x, we can now substitute s squared plus what? Plus 3 in that. So in that case, we are going to have, instead of 3x, we have 3 into bracket. Instead of x, we put this now. That's x squared plus 3. So, and this can be simplified by expanding this bracket. If you do that, you are going to have 3x squared plus 9. And that's the final answer to that question A. Now, as for the question B, we are asked to, the question B says, hence, find the value of f of g of h of minus 2. Now, this is the composite function. And this composite function, we have simplified it to be what? 3x plus 9. So this of minus 2, it doesn't mean multiply it by minus 2. What it means is that whatever this composite function is, substitute minus 2 for the variable. The variable is what? X. Instead of x now, we substitute minus 2 to calculate that. So let's go for that. So the big question now, that's f of g of x. That's f of g of x, which is what we have as question A. So since we have f of g of x, that will be equal to 3x squared plus 9, which is our result for question A. So that's f of g of h of x. Now we are asked to use that to calculate f of g of h of minus 2. So we just slot in this x, we slot it in as minus 2. So therefore, f of g of h of minus 2. So here now, anywhere we see x, we just try to put what? Minus 2. You can see this is x. It becomes what? Minus 2 for this question. So we substitute. That's 3 into bracket. X now is what? Minus 2. But don't forget, it has a square. So we have our squared plus 9. So from here now, we just simplify this. Minus 2 squared is 4. 4 times 3 is 12. And 12 plus 9 will give us 21. And that's the final answer to that question. So with this, I want to believe you understand the concept of composite better. So I have another exercise here for you. That's checkpoint 2. So you take this question as a checkpoint 2. So you try it. Let's see what you can do. If you have any problem, you can always contact me. Thank you.